when I first came, all the research that I did was organic synthesis. So we were basically trying to make big molecules out of smaller molecules, and the objective was usually to make something that had some biological activity. So we did that almost exclusively for years. We got interested in the elephant sanctuary near here. First of all, just because they're amazing animals, but then also we tried to find ways to involve our research expertise and our scientific expertise to help out. So that's grown into a general study of mammalian chemical communication. So we still work with elephants. We have a lot of collaborators at zoos and other institutions, as well as Riddle's Elephant Sanctuary near here. But we have collaborators now, all biologists, who we're working with two different groups to study various types of lemurs and chemical communication from scent glands and urine in lemurs, as well as maned wolves, which are endemic to South America, and also meadow voles, which are a little type of mouse. So that's with a faculty member in biology at the University of Memphis. So that's one big area we're interested in, is how mammals use chemicals to communicate. We've also been working in green chemistry lab development now for quite some time, I guess about 12 years. And this is just trying to make our organic chemistry lab experiments more environmentally friendly. We're going to start revive a project that we worked on some, which is sort of back to my roots as far as trying to make biologically active or potentially medicinal compounds. And we'll start that back up this summer as well. And then we've got a new collaboration with a faculty member at the University of Arkansas for Medical Sciences in Biochemistry, Molecular Biology Department. And that project will involve us preparing compounds which they'll be using down there to study how anti-blood clotting medications work in the body. And I guess one of the most common medicines used against blood clotting is warfarin. The brand name is Coumadin, and apparently it's hard to get the right dosage because one size doesn't fit all too well. So they want to see how the body metabolizes this stuff and try to tweak the dosage better so it'll be more effective. On our end, that involves doing some fairly simple organic synthesis, but making some compounds that'll be useful in their studies. So I like collaborations as good contacts for our students. And also, when you get people working from different disciplines, you can do things that we do which some of my collaborators might think is difficult or something they're not familiar with. It's the same thing with them. They do things that are complementary to what we're doing. So I think it's good to work at the boundaries of disciplines. I always tell people the number one objective of anything we do in research at a place like Hendrix is education. So first and foremost, we're teaching students how to do research, how to ask the right questions, how to find answers, how to interpret data, how to deal with frustrations when things don't work out. So I think that's probably our major contribution, but we also hope that there might be some practical applications of the things we do. I certainly think that's going to be the case with our green chemistry work. So I think our organic labs and our general chemistry labs, we're definitely, with Liz Grahn and some other people, we're definitely at the cutting edge of what's going on around the country in green chemistry education at this level.